Teachers ask lots of questions in the classroom, but many of these are simple recall questions. While these sometimes might be needed, there is much more value in using questions that get children to think and share their ideas. Teachers that do this are more able to challenge and intervene while ensuring they engage their children in the learning.
I've learned a lot in terms of sometimes you've got to be patient and let the kids actually do the work, or give them a task where you sort of take a back seat and you're there for the support rather than taking the hand and saying this is this, this is that, and guiding them through it. So during that, I'm then circulating around the lesson, asking questions, checking understanding, and then keeping a few students on task and providing sort of a push in the right direction rather than a drag in the right direction, if that makes sense.
Start with a very, very open-ended task, because a closed task, like the questions that I was setting, some of the questions I was setting, a closed task won't really give you a broad overview of collectively the group. An open-ended task will help you to see straight away whether they all understand loads of this stuff or whether they all understand none of the stuff, or mix and match.
Rich questions are questions that cannot be answered immediately, but require the student to work on a series of smaller questions or activities before they return to having a go at answering it. Rich questions support students in expressing and discussing their thinking, thus enabling teachers to explore issues that are critical to the development of students' understanding.
Have a little think for me, and I want you to pretend that you're going on a desert island on your own. So you're not taking anybody with you, it's just you. It's going to be really, really hot. And you're only allowed to take 3 things with you. And I want you to have a think, what 3 things would you take with you to help you survive for that week on your desert island? Just have a little think. I'm going to count down from 5, and then I want you to talk to the person next to you. 4, 3, 2. Right, have a little chat in your groups or in your partners, and I want you to share with the person next to you, what would you take with you if you were going on a desert island for a week? You could only take 3 things.
Think. The teacher poses a question and gives pupils thinking time on their own.
So first of all, I'm just going to give you 1 minute. You can close your eyes if you want. I know it's a little bit tricky with the noise outside. Think about all those things that we've just been talking about. Can you tell me what the circulatory system is? What does it do? What different parts of our body are involved in that? Think of those new words you might have learnt, okay? So just 1 minute, have a little think about what you've already learnt. Just on your own first, Scarlett, so you get it clear in your mind. Things that you think, actually, yeah, I now know that, didn't know that before.
Pair. The teacher clarifies what pupils need to try and explain to each other in talk partners.
Between you, discuss, can you explain what happens? What does the heart do? Where does the oxygen come into things? Where does that go to? Okay? Is everyone clear on that? Yeah? So, quick 2 minutes with the person next to you, see if you can explain, and then we'll share together as a class. Off you go.
So doesn't only need to pump the blood to the rest of your body, because if it only did that, the blood would pretty much be useless. So it has to pump it to the lungs first, so that it gets the oxygen. Then the blood comes back, and it pumps it again. Except this time, it pumps it to the rest of your body, and then it goes back to restart the whole process.
Alveoli. I didn't know
Okay,
anything
so
about
where would I find those?
in lungs.
in your lungs? They're like little tiny... What do they have in them?
They have
Air, little air sacs, aren't they? So if you're thinking about our 2 loops, where can you explain? Well, yeah, do you know what? I think a lot of adults think that as well. I was explaining it to someone at the weekend and said, didn't know that. Did not know that.
Share. The teacher then gathers ideas across the classroom about pupils' thinking.
Between us then, I'm hoping that we can explain what the circulatory system is, what it does and how it works. So, would someone like to just start us off, just to give us something that they have learnt? We'll perhaps work from there. Tegan, just give me one thing that you've learnt.
I learned that blood returns oxygen to the lungs for us to breathe out.
So blood, say it again a bit louder.
Blood returns oxygen to the lungs for us to breathe out.
Now, blood returns oxygen to the lungs for us to breathe out. A few of us got mixed up on this. Can someone add to that or explain a bit more on that one? Peter, do you think that's right?
Kind of. Yes.
Can you explain? You're right, we've got oxygen in the lungs, but we need to get this the right way round.
The teacher poses a scenario or a question for students to think about.
Now, just before we go into a little bit more detail here and talk about something called efficiency, I just want to show you a quick video clip just to test out some ideas about conservation of energy. And when you watch it really carefully, because I'm going to be asking you a couple of questions afterwards about it, okay?
So this is a conservation of energy demo. What we're going to do, we're going to get this ball and lift it up to your face where it should get potential energy. When you let go, will it hit you in the face or not? So if you just want to move your nose right up close, and when you're ready, just let go of the ball.
The teacher pauses and allows students time to think. Think, pair, share could work well here. The teacher then pounces on any of the students and bounces the different ideas around the room, building, challenging and gathering ideas without providing any answers themselves.
Quick question before we watch what is going to happen. Harrison, what's going to happen when he lets this ball go?
It's going to move and then it's going to come back and hit him.
It's going to move, come back and hit him, that's what you're saying. Dan, what do you reckon?
I think it's going to come back, but it's going to be at the same point as where we released it.
Okay, why do you think that?
Because it probably goes the same way, and then it comes straight back down and up.
Okay, it's going the same way, coming straight back down. Thinking energy. Kyle, do you agree with Dan that it's going to come back right to the point where he's going to drop it from? Or do you agree with, who was it that said that it's going to hit him? Harrison.
I agree with Dan.
Why?
Energy can't be created,
So you're saying new energy can't be created. Okay, Ollie, what do you think?
It'll go back to the exact point because there will be waste energy within that, meaning it will be going less and less each time until eventually it just stops.
Okay. So, we've got different opinions. Let's see, eh?
And when you're ready, just let go of the ball.
It always scares me.
Rather than asking for one answer, the teacher can ask students to come up with 5.
So in a moment, what you're going to do now is you're going to learn about the different types of energies, okay? What you're going to do is fill in one of these sheets. These sheets, what you're going to do is you're going to collect one from the side, you're going to put the type of energy that you're focusing on. You will also get an information sheet, which will look like this. about a particular type of renewable energy.
Wind farms, we call them tourist attractions, so they'll earn a bit of money from it.
Yeah, what are the negatives?
And then there's no wind, no power, so it only works when it's windy.
Yeah.
And then they can interfere with TVs and radars.
Well, so that's all well and good, but so whereabouts in the world would we get the best use of that then? Because you said there's no wind, there's no power.
Yeah, so the most windy parts of the world, so like the Canary Islands.
Yeah, so there's some examples of where it would be good. Obviously, if there's loads of sun, if you compare it to solar or something like that, which we'll do later, you want to think about its location and where it's going to work best.
Yeah.
Okay, have you worked out how it works? Being a researcher, have you worked out how it works?